so I can always edit first few seconds. It's gonna be too boring.
Sounds good. So, Kim, you had mentioned that you were expecting 6 today, right? So we're just
Yeah,
missing 2, is that right?
yeah.
Right, perfect.
So I'll load for these new students. This is the list of the 6 in alphabetical order. We don't have to follow that or that order, but we could. Yeah.
Should we go ahead and get started, Kim, or do you want to
Yeah.
give it another couple
Yeah.
minutes?
I think so. We've got 4 now. So yeah,
Oh, and now 5, so that's
we got one student there twice. Yeah. Okay.
Yeah, I joined twice because
that was tricky. The question of whether there were 4 or 5 when 2 had the same name, same image. Yeah.
uh,
identity theft, right?
Yeah.
yeah.
So it's nice to see you all again. For those of you who have your cameras on, for those of you who don't have your cameras on, that's fine too. So this class is going to be hopefully quite interactive and full of nice discussion. I know I've been looking forward to it all day. So what we're hoping to do is that just take turns going through these different technology presentations. You're welcome to share slides if you'd like to do that, or you're also welcome to just speak, whatever you find easiest or most conducive to the technology you want to talk about. Kim has been kind enough to make a list, which he said we don't have to stick to. So it's always nice to start off with just, is there anyone who'd like to go first? What I'd propose to do is when we're at that 6 minute mark, I'll just, give you a sign that, hey, it's been about 6 minutes. We don't need to be super formal and cut people off right at that 6 minute mark if they're mid-sentence, but trying to keep to that. So, all that said, anyone wanted to go first?
Um,
Don, it sounds
I,
like you're putting yourself out there.
yeah,
I can go first if you don't want to, but you can go ahead if you wanted to.
okay. Yeah, I'll do it and finish it off. So
Okay.
Okay.
Cool.
can relieve my stress. Okay.
Hey, Don, you take it away whenever you're ready.
Yep.
Cool.
Okay. So good evening, everyone, and today I'm going to talk about absolute happiness, and it's a project called Neuro Happiness, which I'm doing these days as my side project. Actually, it's a little bit of a startup. Um, uh, I wanted to know what's the absolute happiness, so I came up with the idea, and now I'm developing it step by step with different people. So actually, this is a new technical platform. So the in the Neuro Happiness project, we are trying to foster the emotional intelligence and improve the social connections through AI-driven assessments and tools, and talking about a few features. And also, basically, we have things to monitor the biometric and the physiological and psychological parameters of the person to get an overall outcome. And also, this emotional intelligence, the outcome of this whole concept can improve like therapeutic outcomes, mental health outcomes, and also when we are living in the society, it can improve the social well-being of people. So basically, we have a smart device, a wearable device. So it not only monitor the heart rate, but we have sensors to monitor the glucose level, the hormone levels such as cortisol levels, the stress hormone levels, and basically it can detect the person's emotional, mental changes, like sudden changes, and so it's directly connected to the users. And also there are peers, there's a circle of people which are connected with each other depending on their status of emotional intelligence. Like same kind of people like get together, then we have a little bit of a social media platform which they can share their stories, get emotional support, peer support. And if there are drastic changes, we have like professional inputs depending on the request of the users. So the principles should the informatics designs are like first the privacy and security, because it handles like sensitive data of emotional and the biometric data. It should be safe and should be not breaching the privacy of the users. And using AI is also crucial here. And also we are trying to give the full autonomy and take the consent before acquiring this data to develop our big data platform. And also it should be inclusive and accessible, so it should be affordable for each and every person who needs this technology. And transparency is the key when we develop the big data platform. So we have a big data platform which secure the baseline and which monitor the baseline physiological levels and the psychological states and the changes of a normal person, like day-to-day activities and all. And when there's a drastic change, it can alert the system depending on the changes. And also there are like few options whether you need support from a professional, you need support from a peer, you need support from your closest friend. And also if the closest friend is there, he's notified, oh, your friend is in a little bit of a harshful situation, so get connected with him. So this is a big platform which collaborates everyone to get an ideal happy outcome. And the intended consequences are like improved self-awareness, mental health, and early detection of emotional distress, and we can intervene with them. And also it strengthens the social support networks through personalized communities. And the unintended consequences are this is AI tool, because everything is assessed by AI, so there can be bias. Also AI can misinterpret, such as like the first challenge was the heart rate monitoring. So when you run, the heart rate goes up. So we have to come with a solution to differentiate, oh, the person is running or the person is in a stressful situation. So these kinds of challenges are there. And also it's a AI platform and it's in the cloud, so there can be a potential impending privacy risk as well. And the virtues and the qualities, values which we ensure and which reflects in this platform are like empathy, resilience, collaboration, innovation. I'm not going to talk in detail, but I try to keep these values when going forward. And the relationships and the narratives are the personal and the self-improvement through AI guided emotional regulation, and strengthen the family bonds, peer relationships, because I see in the modern world we have a very disordered and disconnected life patterns due to our schedules. But in this platform you can foster each other, you can mentor each other, you can communicate, and you can always be with your loved ones. And it enhances the healthcare integration as well, because we have a physician and a psychological consultation system linked to our platform. So it can lead to like a happiness, like absolute happiness one day. So the existing technologies are like, there are wearable tech devices like Apple Watch, Fitbit, and also mental health apps. But our uniqueness is it's an AI powered emotional intelligence assessment and a predictive tool. And I like to walk through this and see what will happen in the future. Thank you so much.
Thank you very much. So any questions, Jessica?
Oh, sorry, not really a question. I just wanted to give a virtual applause.
Oh, okay.
Thank you.
No,
Thank you so much.
that's also welcome. Yeah.
Thank you, Jessica.
And
I guess I have a
Yeah.
question.
Sorry.
I think, Don, you mentioned that there are like certain measures of, for example, for stress, I believe you mentioned cortisol. I was just curious, do you have like some sort of measure, like a biomarker or something that's related to happiness?
When it comes to happiness, stress level, mental status, there are like with the mental status change, there are physiological changes such as the cortisol level. If we can't predict the cortisol level directly, if the cortisol level is up, the blood glucose level, there will be a change. So we are trying to get the glucose levels and different stress levels and compare them, because right now, actually in our lab, we are producing, like we are in between a production using an LED to get the proper readings of the glucose, because right now in the market we have invasive devices to measure the glucose. There are like very less non-invasive devices, and we are trying to master that technology. So when they develop it, I try to extract that knowledge and compare, like getting data with the stress level and the glucose level, and try to get it like scaled. But if we have like less participants and less data, it will be like not 100% diagnostic tool. But when it comes to a big data platform, I think we can get a diagnostic tool, like kind of a diagnostic tool.
Thank
Run
you.
now. Thank you.
And I'm curious, do you see different considerations of the use of this platform in different populations of people? For example, children compared to adolescents, compared to adults, or people who have mental health issues, compared to those who haven't been diagnosed with such.
Yeah, so the biggest challenge which I see in the modern society is less insight about the mental health. Because physical health, we run everywhere to get the medications everywhere, but mental health, until you come to the level of suicide, sometimes you are not aware of this situation. So if we have this device implemented to affordable price and make it inclusive and available, I think indirectly it will signal you that you need help. It's time to focus on your mental health, and it will notify your closest family member with your consent. Okay, help this person. And if you need psychological support, you can go to a psychologist, because like I think going to a doctor is also challenging. But if the psychologist can assess the person, and try to advocate him and come to a diagnosis, or else can at least do a referral, I think we can prevent these problems. Because like the mental health is also very important, just as the physical body. So I think this will be a good tool to assess undiagnosed um, missing points.
Thanks, Don. I guess the other question that I had on listening, and I'm curious what others think as well, is the notion of unintended effects around dependency, right? Because if you start talking about using a device on a day-to-day basis to, either regulate or, provide you with some kind of guide to, insight or how you feel, and then potentially also mediating between you and others in your social networks for supports, is that a concern if we're using an app or a platform and it cultivates dependency?
Yeah, so that's another issue, because it's like an app is giving you instructions, and it navigates you with a AI driven kind of a thing. It can be biased, and it can be a headache sometimes, but we make sure that everything is consensual. So if the app notifies your peer, if the family member is notified, before that, in the subscription or the initiative, you have to definitely give the consent and that person is also should sign the consent to have the mutual connection. And the social media platform is not to share their data, but to post how they feel. So I think it's like a, like in vigils we see that, like the same people sharing their story, so they know that, you know, there are another people who are having the same problem, and they can form supportive groups. And for that platform we have a strict monitoring system, not to post like negative stuff, only to overcome challenges and to build their uh, life.
I'm mindful of time. Are there other comments or questions that people had? All right. Thanks so much, Don. That was really interesting.
Thank
Why
you.
don't we move on to who else had volunteered themselves? Was that Jinan that I heard?
Yeah, it was.
All right. Well, you're up.
Okay, perfect. I'm gonna share my screen. Oh,
Looks good, Jinan. We can see it.
Yeah, you're not hearing you though.
Jinan, are you talking? We're not seeing anything from your microphone, so just checking. Hmm.
She's frozen at her end or something. She says, huh, oh,
As the host, do you want to stop her share and then maybe move to someone else, and then we can come back to Jinan in a bit and see if the
sure.
connect
Let me
better?
see. Okay.
All right, so Jinan, we'll come back to you.
Yeah, she's actually no longer here, so I think she was in the process of
Reconnect.
crashing out or
Oh
crashing
dear.
back in or whatever. Yeah, let's
Oh,
just
there
see.
she's back. We'll give
She's
it
back.
another go.
Yeah.
Hey, Jinan, can you hear us now? Hmm.
hello?
Hello?
Yeah.
Hey, sorry, I don't know why I got kicked out.
All good. We weren't able to hear you when your slides were up. Do you want to try again and see if it
Yeah.
works?
Yes, I'll try that one more time. Sorry about that.
No worries.
Can you hear me?
Yep, we can hear you.
Okay. Okay. My computer is just absolutely so slow right now. I'm so sorry about this. All right, there we go. I'm just going to share my screen. Okay, there we go.
Yep.
Is this good? Are you guys able to see it?
Yes.
We can see and hear you.
Okay. Okay, perfect. So I'm going to be presenting on Neuralink and the future of medicine. And so first we'll start off by like addressing what is Neuralink. And this is a company founded by Elon Musk, and his idea was just to create a direct link between like the brain and external devices using implanted chips in the human like brain, I guess. And their goal was to like restore neurological function and enhance human cognition and enable seamless interaction with technology. So the idea about like how Neuralink affects human interaction, there's like multiple ways we can go about this. And one of them could be enhanced communication. And for throughout the presentation, it might seem like I'm supporting this. I have my own thoughts on this, but so basically, it could help patients with paralysis or speech disorders, or like for them to be able to communicate with other people through their thoughts alone. Um, Again, this could be really helpful for like for healthcare, because there are a lot of patients who we are unable to communicate with, specifically like I said, like people with paralysis, when they're either bedridden or they're at home or they're in the hospital. We don't know what's going on inside their heads or how they're personally feeling. We can only assume, and so this would be able to help kind of like break that barrier. Um, there is a couple of ethical and social concerns, specifically with like the cognitive divide between those and with and without Neuralink. For example, if we start implementing this for everyone, um, and then there are some people who aren't able to have Neuralink, or they aren't able to get it implanted. Will there be a divide in how fast people progress, for at least those with Neuralink or those without Neuralink, like, and vice versa? And then it also raises questions about privacy, autonomy, and again, hacking risks, for the neural data. There are some principles that should inform Neuralink's design. For example, like the safety. How safe is this for the human brain? We know that like in order to get it in, it could be a pretty extensive procedure to be able to put it in your brain, but also like the long-term risks. How bad is it for one's body to have a chip inside their head? Is it going to be accessible to everybody? Or is it only going to be accessible to people who are wealthy and, first world countries and things like that? There's also like being able to have surveillance on the mind constantly. Is that something that would be misused? For example, who has all this data and who's able to control it and things like that? Also, user autonomy. Users, they must be able to have their own control over their own data. But then again, is this something that's possible for everyone to control their own data and things like that? Some intended consequences could be restoring function in patients' neurological disorders, again, like ALS, Parkinson's, and paralysis. And it could also help improve cognitive abilities and brain-computer interaction for daily tasks. And it can also help advance neuroscience. So basically, if we're able to know a person who's paralyzed, what they're thinking, or how this affects their mental health, or how slow their thoughts are, for example, in comparison to a person who's not paralyzed, or like just differences that we're not able to see personally, as doctors or anything like that, like doctors aren't able to see. Like, is there something that we can understand through that? And again, the neuroplasticity of the brain. So just basically understanding how the brain changes and everything like that when you have ALS or Parkinson's or paralysis. Some unintended consequences could be risk of hacking or unauthorized control over the device. And again, the potential economic disparity. So the difference between wealthy, with those who can afford Neuralink versus those who can't. And then psychological and identity concerns. This changing brain function affect self-perception. I think we talked about this in another class, where we talked about basically it's kind of like I don't know the name of the cat in the box, but the idea like it's either dead or alive.
Universe. Yeah.
Sorry?
Schrodinger's cat.
Yes, yes, exactly. It's the idea that it's like either dead or alive, but once you open the box, yeah, it's both dead and alive, but once you open the box, you confirm it. The point is that like when we observe some things, it changes how they start acting. So if we're constantly observing the brain function and things like that, how does that affect the person? Or how does it affect self-perception? Or how does it affect how they go about life, knowing that they're constantly being watched or recorded, or especially their thoughts? Um, some values and virtues reflected in Neuralink. So again, it pushes the boundaries of medical technology. These are things that we have never seen before. At least maybe people have, but in other ways, but at least I didn't know much about. And again, it would be designed to assist the individuals with disabilities. But then again, it raises the concern about who controls the technology, and who has access to all this data, and how autonomous is this? And like Neuralink compared to other technologies, we've got the DBS, and this is used for Parkinson's, but however, it lacks bidirectional data exchange, and BMI, which is brain machine interfaces, and they're neural implants that it, they allowing movement control through your thoughts. Um, some features, however, about Neuralink that are different is that they are wireless, unlike the BMI, and they have a potential for AI integration. And this, again, can help with learning and adapting for neural activity over time. And the broader implications include like things beyond medicine, like cognitive enhancement and digital communication. Again, digital communication, we do have that already through our phones, but the idea that like it can be just like through your thoughts and it's kind of sent. Thank you so much.
Great.
Thank you
Thanks.
so much, Jen. Thoughts, questions, comments?
I have a question.
Yes.
Yeah, so if it's commercially available, will you take it and get an implant? Because I think like there are some advantages of therapeutic as well as like superhuman abilities. Like I think like good memory, AI assisted thinking and rationalizing. I think they are giving those benefits as well. So as the presenter, and do you think that uh, if it's commercially available, you would like to get it? And
I, to be honest with you, I personally would not, unless I need it. So if I'm in a situation where my body really needs Neuralink and doctors are trying to, for example, figure out what's wrong with me, or there's something going on where I'm in, like, again, I'm in need of it, then I would. However, it's just commercially, to be honest with you, it just also depends on how many people also have it. If the world is moving forward and now everybody has the chips, and just like our phones, like if you can't get a job without having a phone or an email, or being able to communicate with others, or getting to school, I need navigation, for example, or things like that, or being in contact with my family. If it's something that everybody has and the world's moving forward with Neuralink, then I can't say that I wouldn't get it. However, if it's something that had just started happening and not many people have it, or it's very expensive, or it's not really accessible, I would not say that I would get it, only because it's, again, we don't really know the full risks of it, the long-term risks. And yeah, honestly, just it's very situational. So yeah, I would not say that I would now, but like I said, I would never know if it, like, at the end of the day, everybody has it. Yeah.
thank you, thank you.
Yeah, of course.
And I'm curious about your thoughts of um, how people would consent or otherwise enroll in these kind of experimental applications of a technology. Often in medicine, when we're trying a new technology, like a medication, for example, we start off, with animal studies, and then from there we begin with, people who have quite severe disease, right?
Mhm. Mhm.
Um, how would you go about something like this when potentially, like you said, the goal is enhancement uh,
Mhm.
rather than therapeutic?
Yeah, so honestly, There are a couple things that I would say about that. The first thing is I understand the phases of the phases of, for example, releasing a drug, and we have to make sure it's not lethal and things like that before we're able to just give it to everybody in the world. The thing is with things like this, I don't know if it's like illegal to have people who aren't that don't need it like medically to be able to try it first, and like first it goes through animals, and if the animals are okay, a few people who don't need it, so we can just see how it works. Like, do the thoughts actually get integrated? Do these things actually work? Like, I don't think that giving it to a vulnerable population to begin with is very ethical, especially because even if we do hear a thought or two, or one thought or two gets communicated, we don't know if that's because the person, for example, who's paralyzed only did have a thought or two, or that's all that was communicated through the device. So just a lot of room for error when we don't really know how the device works itself. So that's why it'd be better to do it for people who can consent and who can say, yeah, like, as long as I won't be very harmed with it, like, or I won't be harmed, I'm willing to try it out. And at the end of the day, worst case scenario, it doesn't work in that situation. However, for people with diseases or things like that, for example, how do people who are paralyzed and aren't able to speak consent to a new medicine that comes out anyway? Are they able to consent? Are they able to say, yes, let's try this drug? Or do we just give it to them? Or do we ask family members? Or is it kind of like, this is a genuine question, by the way. I don't know how that works, because if that applies in that situation where a person is unable to consent to a medicine, but we give it to them anyway because we believe it's for the greater good. If Neuralink is able to advance far enough for us to be able to just implant it, then, and it'd be very, very good for the patient, then is that not something that we could do?
Eugen, it actually gets very complex, right?
Yeah.
Um, in many ways, if someone can't consent to a treatment or an intervention, then to try it out on them, you're truly experimenting on them rather than with them,
Mhm,
right? So if someone can't consent to something experimental, it's very challenging to go down that pathway.
mhm, mhm,
Um, it's also challenging because if we start thinking about disability as disease or something wrong that needs to be corrected, what does that even say societally about someone's life who is disabled or who has differences in their development?
mhm,
So there's also that's often been raised in such situations. That being said, I mean, clearly there are people experimenting with different kind of implantable or, um, you know, um, neuro brain stimulation studies, and they generally are people who can provide some degree of consent.
mhm,
And there are all kind of ethical safeguards that are put in place to make sure there's, no coercion, there's appropriate safeguards if there's risks or adverse events and so forth. But it is a very complicated area dealing with experimental therapies and novel
mhm.
technologies.
So in pig to human transplants, it's very dramatic that no one thinks you should put a pig kidney into a normal person. But a
Mhm,
number of people think that it's theoretically a really good idea. It would tell you many things that we now won't know for decades by only putting pig kidneys into, diseased people. So it's a fascinating thing that you can get people who are willing to talk about it for a long time, but only with the idea that, of course, we would never actually do it, but it would have so many benefits, to do it. Then when you take the people who are willing to accept something like that, many people have the prejudice that if they accept it, there must be something wrong with them, right? Isn't it possible that there is nothing wrong with them? But yeah, most people don't think so. So it is if you have any therapy that you never ever gave to a normal human, it's sort of hard to know what it does in the normal human body, right? It's a piece of information that you'd really like to have.
I hear you, Kim. It is challenging though, right? When we start talking about the normal human body, because what is the normal
Yeah,
body and who gets to decide that?
yeah,
And the moment we start talking about using people as a means for gaining some knowledge, that's really important. I would really like to have. We're
yeah,
still reducing those people to a means.
yeah.
Um, I think a good starting place, Jinan, if you and others are interested about kind of research ethics, would be reviewing the Tri-Council policy statement. That's the one of the big organizations that oversees human research in Canada, and they have a very nice free course you can take on research ethics.
Mhm.
We should probably go to the next person.
Yep.
So, who wants to put up their hand next? Volunteer consent for this stuff.
I will volunteer myself to go next.
Okay, great.
Thanks,
Yeah.
Zoe.
Yeah, I actually have a very similar topic to Janine's, so I'll try to focus on the things that are different, and highlight maybe some of the things that she hasn't mentioned already. So, the topic that I wanted to kind of bring to everyone's attention for discussion today is on brain-computer interfaces, or BCIs, what we're going to call for short in this presentation. So I know Janine already alluded to this, but essentially BCIs enable direct communication between the brain and external device. And this is usually done in a form of an implantable external device into the human body, like the Elon Musk Neuralink example. It has great potential in medicine. It's just to name a few examples, it's able to enhance mobility for paralyzed individuals, as well as treating some of those neurological disorders, like we've already kind of learned about. And again, at the same time, though, it could raise concerns about privacy, identity, as well as the notion of human augmentation. And ultimately, I think the discussion is that I think it will alter how we form relationships. If people are able to share thoughts directly, what happens to personal boundaries? Are we potentially entering an era where we just have to stare at each other to know what we're thinking about? And what kind of dangers can that bring? So I thought I would share a success story as well, just so we can kind of see how it's used in medicine today, as well as its applications. I briefly discussed like some patients with locked-in syndrome, or ALS, amyotrophic lateral sclerosis is the technical term. They're completely unable to speak or move. And scientists with the BrainGate Research Consortium actually developed these implantable sensors in the brain that are able to translate brain signals into speech with up to 97% accuracy. I won't go into the technical details, but the diagram on the side here just kind of illustrates how this works. Essentially, you have external sensors that are implanted into the brain regions associated with speech. And then you would be able to extract neural activity signals that are then translated into neural networks, like we've already discussed in some of the more AI lectures. And then essentially, the algorithm is able to predict what the person is wanting to speak based on their language model. And this would be displayed on an external monitor with the patient connected to it. And this BCI specifically actually allowed a patient by the name of Casey Harrell basic communication skills with their caregivers who had ALS. Obviously, the intended medical use is already very evident, but I guess along with this, it comes with unintentional consequences, such as potential surveillance of individuals who are using these BCIs. It can create the loss of mental privacy and just overall ethical concerns about cognitive enhancement. I've listed here 3 brief principles for design I think that should be taken into consideration. The first one is we should always prioritize user autonomy as well as informed consent, we've already discussed. It should also be secure enough to against hacking as well as unauthorized access. And overall, it should focus on the medical benefits before non-therapeutic enhancements like cognitive related. Overall, I think BCIs remind me an awful lot to prosthetics, but the only difference is that it operates more on a neural level as opposed to just physical enhancements. I think it has the ability to redefine human-computer relationships, and ultimately, it kind of blurs the line between human cognition and machines. And like I already alluded to earlier, I think it will, if this ever becomes common enough that everyone will be have access, I think it will enable new ways of social interaction, such as like direct thought sharing, for example. And then I thought I would end the presentation with a couple questions, maybe for discussion, as well as questions for a little bit of reflection. Ultimately, who regulates these neural interfaces? Is it the third-party companies who design these devices, or should it be health authorities and government bodies? And to what degree are they reliable, right? And ultimately, should neural data be protected like medical records? I remember Dr. Soles actually mentioned in a previous lecture where to access patient medical history in Alberta, at least, Connect Care, the platform is actually highly regulated. And so, should neural data be protected just like these? But ultimately, who is protecting them and who has access? And then finally, just are BCIs an assistive technology, or do you think they're going to become a performance enhancement tool? Those are some things that I thought might bring up some discussion.
So
Thank you.
the idea of communicating via thoughts, I think people vary a lot in how appealing that idea is or practical. There's a recent TED Talk, which when you just listen to it, it sounds so improbable. The guy is saying that although text has been the predominant way humans have communicated for thousands of years, that by the end of this decade, video will replace completely text. That, in instances where we would have used text, we'll now use video and so on. And I just think that without positing anything else, the chances of that occurring are practically zero. But if you could also communicate via thought, then I think that would change a lot of things. And maybe then when you're doing that, video becomes somehow more appropriate to the human situation than text. But it's just very interesting. I have like 1,400 plus videos. Most people would say in an academic setting that they're absolutely worthless. Like you don't get any credit for it. But you can imagine if what this guy says is right, that I might get a lot of retroactive credit for all those videos eventually when video replaces text. So what do you guys think? I mean, I think that a lot of young people don't start using email until bigger, older people start telling them to, because there's so many other things that are faster, right? So is that the way your life has been, or did you sort of like email from the beginning, or does it seem old and clunky to you?
I guess I think to address the first part about whether or not video is going to replace text by the end of um, a certain time frame, I think we're in a constant stage of like adaptation.
Right.
Initially, when telephone was first introduced, people were very against it. People still preferred writing in letters. And then now we think phones are very essential to our daily lives. So there's definitely a degree of adapting at a societal level.
Yeah, but right now in the academic world, text gets a lot of respect, right? Various kinds of text that
But
video certainly doesn't.
I mean, just to shift it a little bit, one of the things you're talking about, this idea of so-called reading or sharing others' thoughts, is you're speaking about language, right?
Right.
Um, but what's interesting, of course, is we're not always I mean, when you start using language, whether it's in a video or whether it's in written documents, you're making sense of an experience, right? Like we're not always able to put our emotions to words, right? Some people need to go and see psychologists, for example, to help make sense of how they're feeling. So one thing that's really interesting about the idea of a neural interface is what would actually be shared?
Mhm.
Would it actually be text or would it be impressions?
Yeah.
Would it be
Feelings. Yeah.
feelings and but not even necessarily feelings because even when you use the word feelings, you're putting a name to something like happy or sad.
Right. Yeah.
But, you know, that sense that comes before we put a name to it as a feeling. There's literature that talks about how when babies are born, they don't necessarily differentiate themselves from others around them, right? So in a way, they're kind of experiencing the world in a mediated way, right? They're being affected by, you know, how others speak, how others talk, and so forth. Can you imagine living in a world where you're constantly affected by how others around you are feeling, right? What kind of chaos would that potentially be in? Like if you go to a hockey game and the crowd suddenly gets all energetic and excited, and you start to feel that as well. It's like a contagion, right? I'm starting to get into psychology here, right? So is that the kind of world
Yeah.
you would want to live in? I think that's a fundamental ethical question that could be asked of all of these technologies. So what do you think, Zoe? Do you want to live in this world?
I think that's a very difficult question. Um, if I were to give a simple answer, I would say no, because we're so used to kind of working around ourselves around language, so much so that language is a very reliable form of communication in society today. But I can definitely see the benefits of also being able to exchange more abstract feeling ideas or the notion that comes before feeling. I think there's definitely pros and cons, but yeah.
Would this be something that would be like a form of intimacy, right? So if,
Yes,
when you're
yeah.
in a really, you want to get serious with someone, let's join our neural
Mm,
interfaces, right? So,
yeah.
it's curious to think like what forms of intimacy might this afford in the future,
Mhm.
right? Anyway, great presentation, Zoe. So far, all these are really great ideas. I think we're either up to Barbara or Jessica.
I can present
Oh,
if you want.
Okay. Yeah.
go ahead.
Yeah. Yeah, I don't know if I spot on the assignment. I got very impressed by the our lecture last time, and I thought about what is ethical in the daily life. And what I want to present is another like kind of technology that we usually use. I will share my screen and let's see. Can you see my screen?
Yeah.
So what I will present is an app that it's used for tracking our calories. It's a technology, like a non-conventional technology that we use on the daily life. And I want to ask you how many of us will usually track our food and or counted our calories. And Yatsu is a very popular nutrition and calorie tracking app that offers multiple options that are constantly shaping our view of food, diet, and it's constantly giving us stimuli of what an healthy lifestyle is. But how these impact our health, relationship, and well-being. There are, of course, some positive aspects of that in general have spread, and especially in the young generation, especially thanks to the backup of the social media. And this is giving us a more like awareness of what healthy lifestyle is and needed, encouraging people to track their food and what a good intake is. But there are some negative aspects that, for example, is causing guilt and stress and also a food obsession because we are constantly checking our phone because we need to track, for example, oh no, during breakfast I ate a bagel with bacon and cheese, and then I drank a coffee more than needed. And so it constantly put in our mind a thought of counting the food and the calories that we are assuming. And this is can be very detrimental for our mind, especially if we have eating disorders. And also, it is a challenge in our society because it can impact our motivation, especially if we don't see results. For example, we have a specific goal of losing some weight, and then we don't see the result after losing the diet. And if we are talking to our friend and we are following the diet that the app proposed to us, this can lead to unhealthy competition because our friend lost weight, but we didn't. And then it's like, oh, she lost weight, but I didn't. And I have to keep up, and I cannot like lose the time, and I have to eat less food because this is not good for me. And she cannot be better than me. So this is extremely unhealthy for us. So which can be the principles for an ethical design of the app? For example, a nutrition education for the app, because we need to have an extensive information about what is very important to assume during the day in terms of food. So we have to have a comprehensive information about the food and the calories. And of course, a very good advice should be, for example, a disclaimer that we need the information given by the doctor. So, for example, a pop-up telling us, please don't forget to go to your doctor and do a checkup. Because it's important to tell the user that this app is not a substitute of a good diet and a visit from the doctor. Also, it's very important to to have personalization in our plans because we can have comorbidities. For example, we cannot have a plan that suits all of our habits. So, for example, one plan for me is not good for Zoe or is not good for Jessica. It's important that we all have personalized plan because I'll give you an example. I'm hyperinsulinic. So if I assume high values of carbs, this will increase my level of glucose in my blood, and this will basically help me in gaining weight. So in the end, even if I'm following the plan that they are giving me, I will still gaining weight. I will lose my motivation, and this will change my relationship with the food. And I will lose my motivation, and I will say to myself, I won't be able to lose weight, so I will give up. And I possibly, like in the worst case, I will develop an eating disorder, and I will took a path that I cannot go back. Also, another concern is the privacy, because it has proven that this kind of app, like Yazoo, can sell the data to brokers or the market. So we need stronger encryption for the data protection, and also there can be data breaches or violation and identity theft. So it is important that additional measures for protection are taken for the users. And more importantly, their inclusivity for the users. Because of course, the first thing when you are setting up your profile in the app is the gender that they ask. So this is a very big limitation that the app has. So for example, you cannot select if you're binary or non-binary. You can only select if you're male or female. And this is an ethical concern. So inclusivity is a big principle that they should consider for the ethical design. And also cultural and religious and of course health-related needs. So if we have to consider intended and unintended consequences, of course, there are some good purposes of the app because they want us to manage our calories and track our food during the day. And also, like the idea is that we develop a diet intended as a healthy habit, which is good in a way that we understand that we have to keep a structure during the day of what we are eating. But there are a lot of bad consequences that they can happen. And for example, the worst case is the mental strain for the constant tracking of the food, and also the possible eating disorder that we can develop. And this is mostly because we live in a society where the trends are constantly popping up. And this is because also social media are pushing whatever comes in their way. So basically, TikTok is an example. And wherever it's in the reels, it becomes viral. And these apps are these, yeah. Do you want
You're
to
like-
say?
Oh, I was going to say you're just now at about 7 minutes.
Okay.
So, yeah.
Oh, sorry. I will close up. So if we think about the values the Yazio reflect, there are some good values like discipline and self-improvements, awareness, but there is the risk of perfectionism and over-tracking and over-control. When we compare to other technologies, there are a lot of similar apps that we can find on the phone. But Yazio, the good thing is that integrates fasting tracking and meal plans, and there is a good structured guidance for the self-tracking. And I want to conclude saying that for sure we have an health tracking of the food, but there are some important ethical concerns that we need to address. And one thing is that we need to focus on our mindful eating. And one question that I wrote on the presentation is, are we using these apps or are they using us? Thank you.
Thanks, Barbara. Thoughts that people had or comments? One thing I wonder, Barbara, as I was listening to your presentation is, sometimes individuals choose to use an app, but other times an app is prescribed to them, or potentially even, people could be pressured into using that app, whether that be by a partner, a social group, even by someone's parents, right? Um, are there any kind of safeguards in place that, allow someone to kind of decide, how much they share and so forth in these apps?
So the problem is that there aren't very clear guidelines in this specific hub, and this is the ethical concern that I wanted to highlight. This can be one suggestion that they can improve in terms of privacy and guidelines for the sharing of the data. When it comes to prescribing the app, for example, like because there can be doctors that can prescribe specific app. In
Yeah.
general, they have app developed specifically for this like by specific system. These are more general apps that are developed for like marketing purposes. So generally speaking, they don't really care about how they treat the data. And this is like the problem when it comes to how they treat the data of the patient, the users, and how they manage the information that the user are giving to them.
I don't know the answer to this question. Maybe you or others do. If there's an adverse event as a consequence of someone using an app, can the app designer be sued, or are there precedences of that in Canada? Because like for drug manufacturers, for example, I mean, people report adverse events and at times there's been examples of people suing the drug company because, some information wasn't disclosed. But apps I'm not sure about, so I'm not sure.
Um, Usually, like as we know, if it's a medical device or a medication, we are coming through FDA. But if the app is linked with communication and all, the governing body is, I think, FCC, like the Federal Communications Commission. So if there's a problem, you can always report to them. Up to my knowledge, I'm not very sure. And but clearly, like there is no clean cut um, evidence for suing and all, because it's like when you download the app, I think you have a consent form, and like I think when you click it and you place I agree without even reading anything. So I think
Well,
there will be the
in medicine, there's so many things that are in theory prohibited. Physicians can do things non-physicians can't do, and all that kind of thing. But when you think of the world as it's unfolding in front of us, you just know that somehow some of those limits are going to be taken away. We don't know how, but like right now, there's not many instances of high quality medical care being provided in areas where there are no doctors, no nurses, right? Just the information. But eventually that will be very common. And then who's going to act on it? Right? So it just I think we'll change rules that we think we would never change. And there'll be things that doctors currently are the only ones who can do things. And eventually that will change because it's just not reasonable in some future scenario. And eventually machines will be better at many things than human doctors are. And you could use the regulatory side to say it doesn't matter. They'd never be able to treat a patient because the law wouldn't let them, right? So just think about that for a minute. If that's the only thing preventing a physician who's much better than a human physician, then eventually those laws will be changed. So, yeah, as shocking as that may sound.
Yeah. Well, and that's partly why I was asking about, legal cases, because often it's, judge-made law, so case law that ends up kind of stimulating either legislative change or change as far as, constitution or higher levels of court. So you sometimes get a peek or a sense of where things are going. We should move on to Jessica, but thank you so much, Barbara. So we'll move on to Jessica as the final one for this afternoon. Take it away, Jessica.
All right, I'm just gonna share my screen here. Oops, wrong one. Okay, can everyone see my screen?
Yeah, we can see it. It's not on full screen, but we can definitely see the slide in the middle of it, if you know what I
Oh,
mean.
yes. That's weird. We'll work with it. Okay. Oh, let's see if I can fix that. If I slideshow it like this, it's still a little bit on the smaller end, I'm assuming.
We're seeing your little click to add speaker notes. I think you're sharing the whole window, if that makes sense.
Oh, okay. Hold on. I'm just gonna stop the share for a quick second. See if I can.
But if not, don't worry. We can always zoom in on our screens, I'm sure, on our own ends as well.
Thank you, thank you. I hope it works this time. If not, yeah, for some reason I'm not able to get it on the big the big
It's
presentation.
it's
Sorry.
all good, Jessica. We can still
That's
see
fine.
slides
Yeah,
and we can hear your voice well.
yeah.
All right, I'll just carry on. Pretend like it's big screen. So today I'm just doing my presentation on advances in imaging techniques, specifically in acute ischemic stroke. So the imaging technique I used today or chose today was CBCT or C-arm cone beam CT. I moved to the next slide. Are we able to see that, or is it still like on the title page?
Still on the
Go
title
on
page.
the first slide.
Still on the title page. Oh no. Okay.
There
How
we
about
go.
now?
Yeah,
Okay,
yeah.
awesome. So basically, C-arm cone beam CT is a modern imaging technique that provides detailed 3D images by combining traditional X-ray methods with advanced 3D reconstruction. So unlike conventional CT scans, CBCT rotates around the patient, capturing multiple 2D X-rays from different angles, which are then compiled into a 3D model. And this technology offers real-time imaging for diagnosis and treatment decisions in stroke patients. So I have a video here that kind of shows how it works. I hope the video works. Yeah. Okay. So essentially, yeah, it's an imaging technique. It kind of looks like a big letter C, and essentially it rotates, and you would have like the patient laying right here on the table. And so as the arm rotates, you would get real-time imaging with this device or technology. So why CVCT? Essentially, CBCT impacts patient care, medical workflow, and decision-making in emergency stroke cases. So, by integrating imaging and intervention within a single suite, CBCT eliminates the need for patient transfers, reducing treatment delays. And this creates a faster and more coordinated response to stroke where every minute counts. And then, what principles should inform CBCT's design? The design should prioritize the following. So, first and foremost, patient safety. And this is by minimizing radiation exposure using region of interest imaging or ROI imaging, which reduces unnecessary radiation by approximately 45 to 50%. And then speed and efficiency. So, optimizing protocols to reduce motion artifacts and acquisition times, which I'll talk a little bit more later. And this essentially ensures clear and reliable imaging. And then lastly, accessibility. So ensuring the system is adaptable to various clinical settings and environments. Moving on to the intended and unintended consequences. So one of the intended consequences is that CBCT offers this concept of a one-stop shop for stroke care. So by combining diagnosis and treatment in one location, CBCT reduces door-to-needle time, so potentially improving patient outcomes. And then one of the unintended consequences is that it can potentially produce motion artifacts. So this is essentially creating kind of like blurry or ghostly images. So we can see here that if a patient is moving under imaging, that the image can kind of appear blurry and ghost-like, as opposed to if the patient isn't moving, we get a more clear picture here and just a higher resolution image in general. And then I kind of created a table here to compare some of the existing technologies with CBCT. So some notable things here on this chart is that CBCT offers real-time imaging and it lowers radiation exposure. So we can see that with the ROI-based imaging, it creates lower radiation exposure as opposed to traditional CT or MRI imaging or CT imaging. But yeah, that's just the table here. And then moving on to discussions. So In terms of time efficiency, CBCT enables a one-stop shop workflow combining imaging and treatment in the same room, and this eliminates patient transfers, reducing the time from stroke imaging to treatment. And then the second is dynamic monitoring. So unlike CT or MRI, CBCT provides real-time imaging, allowing dynamic monitoring of blood flow during procedures. So kind of having everything you potentially would need for stroke treatment all in one room in one location. But yeah, that's essentially just my intro to CBCT and its potential future use for stroke care. But yeah, thank you for listening and welcoming any questions or comments at this time.
Thanks so much, Jessica. Thoughts, questions? You know, it's interesting whenever people present a technology which seems like just an interval improvement of previous technologies, right? So, oh, is this just a better CT? Usually people don't notice that there's any particular ethically challenging issues with it. So one of the questions that I would ask is, you know, for people who would train with this kind of technology, would that limit their availability to practice in other places of the world where they might not have such technologies available? For example, you know, in where I work in the newborn intensive care, you know, some people only know how to put in, um, you know, certain kinds of tubes or needles using ultrasound or other devices. So that limits their ability to provide service in under-resourced areas. So is that a potential issue here?
In terms of training and how that would look in comparison to CT, I would say definitely don't have the professional answer for that. I would say there would be a little bit more of a shift, and I think there is a reason. Like I think new technology definitely gives like novel ideas and new perspectives when it comes to treatment in the medical field. But another thought is kind of cost and accessibility as well, just because having like this device is not really isn't practical, for example, in a small town. Like they probably wouldn't have the space or the budget for this type of device. And then second, I think sometimes there's reasons why the traditional way is still here as comparison to like novel new ways. So in terms of training, it probably would look a little different in terms of like you would need to be able to like have like radiology and have a lot of different departments probably either all working together on this case or having the training for all of these different types of areas. But yeah, I think the concept is definitely cool and it's there in terms of stroke care and like the idea of a one-stop shop. But in terms of like the future and where CBCT could go with stroke care, definitely think there needs to be a lot more research and just discussion into the practicalities of having this device and the training it goes into and just the differences when it comes to traditional stroke care as opposed to CBCT future care, if that makes sense.
It makes sense. The other question I'd ask is, are there any particular groups of patients that would be either disadvantaged or advantaged because of this technology? For example, you know, sometimes with circumferential imaging, there are limitations on body size, where someone who's overweight, for example, wouldn't be able to benefit from the technology. Or, you know, potentially the opposite, like if you're taking care of a baby and they need, you know, breathing tubes and other equipments on the table, that might interfere with the operation of the device. So, in what way is this technology responding to the diversity of patients that we're responsible for?
Mhm. That's a very good question. When I was looking into this device, it definitely was pushing on the aspects of benefits where because it is in one location and the patient doesn't have to move, it would potentially be more beneficial for like the elderly population and just like it would be less taxing for them in terms of like moving from room to room and like it reduces that time to um like go from like a CT scan to a treatment room or like the procedure room. But I definitely agree in terms of populations that are able to move or have other treatments or other devices that they would need to be connected to, it could potentially definitely impact how the CBCT like scan could operate and move itself. And then if those devices or if those mechanics are like affected, then it affects the imaging, which then affects the treatment, and then a lot of things could go wrong or not go as quite as planned. So I definitely think there's some pros and cons, but yeah.
Sounds great. Any other questions or comments for Jessica? Or for the session in general? Because I think we're approaching that 3:20 mark on time, I see, right, Kim?
Yeah, yeah. No, I think this is something we should keep on doing. And, it's kind of innovative in that you're not being graded. And also, every time we've done it, there have been students who are ill or wouldn't they be able to take part. And so it kind of makes sense that it's not graded, but it also makes really good video if the time comes when video counts more than text. These will be really good videos. So that's cool. So I do think we should keep on doing it. Yeah. So thank you all for taking part and for your efforts to get ready for today. Yeah, and if I were going to grade it, I think all of you did well. I have a hard time, I think, differentiating. Yeah, can't think of who'd be at the bottom and who'd be at the top. So anyway, I think you can all be proud of what you did today. So there. Okay, so I'm speaking on Thursday about AI optimism and the special status of Canada. I believe in any other country, you can't really argue that the future is necessarily positive, but in Canada, for reasons I will outline, you can. So how about that, eh? So anyway, I'll look forward to interacting with you about that on Thursday. All right. Thank you all very much. Bye-bye.
Thank you.
Thank you.
Bye.